All right, this is Honors Algebra 2 Pre-Calculus, Pre-Calc section 9.3, which is geometric sequences in series, and we're doing example 1. So example 1, we're going to identify whether a sequence is geometric, and if the answer is yes, then we're going to find R. So let's look at example A. So in A, we have a 2, a 6, a 10, and a 14. So if I were to multiply 2 by something to get 6, it would be a 3, right? So 2 times 3 would give me 6. But if I do 6 times 3, I don't get 10. So the answer right away is no. If you wanted a mathier way to show that it's no, you could show that 6 over 2 is a 3, but 10 over 6 is clearly not a 3. Like, you don't even have to simplify it. You can just say, hey, I get it, 10 over 6 is clearly not a 3. So the answer is no, it's not geometric. If I were looking to find in B whether we have a geometric sequence, I can look at what I multiply 5 by to get 15, which would be a 3. I can then say, do I also multiply 15 times 3 to get a 45? Yep, that checks out. And then 45 times 3 to get a 135. So the answer is yes, and my common ratio, rather, my R, is a 3. Sorry, I did a D like it was arithmetic, which, by the way, A was arithmetic, right? If we were going back, A is not geometric, but A is arithmetic with a common difference of 4, right? 2 plus 4 gives you 6, plus 4 gives you 10, plus 4 gives you 14. So for the record, A was not geometric, but it was arithmetic. So B is a geometric sequence. And again, if you wanted a mathier way to show that, 15 over 5 is the same as 45 over 15, which is the same as 135 over 45, and in all of those cases, it's a 3, right? Now, you don't have to show that necessarily, but you just have to be able to spot that it's geometric. C, if I look at what I were multiplying 1 by to get 4, the answer would be 4. But then if I do 4 times 4 to get the next term, I don't get a 16, I get a 9, right? Now 16 shows up, but not in the right spot. So again, this is a no. Now, again, you can show it in a mathier way, right? It's a no. You can show it in a mathier way if you want by showing that 4 over 1 is not the same as 9 over 4, which is not the same as 16 over 9, etc., right? That's fine. The thing to notice, again, is that, as we've seen previously, just because something's geometric doesn't mean it's not a pattern. You can definitely see the next number in this sequence, but being a pattern doesn't mean that you are a special kind of pattern, right? Geometric is a special kind of pattern. And then I think D is tricky just because people don't really like fractions and they don't really like negatives. But if I say to myself, what am I multiplying this 3 over 1, because 3 is actually over 1, by to get a negative 9/4, well, I think that what I'm multiplying by is a negative 3/4, right? If I times this by a negative 3/4, I would get negative 9/4. And I can say to myself, am I doing the same thing to get the 27 over 16? And sure enough, if I were to times a negative 9 over 4 by a negative 3/4, that top would become a positive 27 and the bottom would become a 16. So that checks out. And then if I were to multiply the positive 27/16 by the negative 3/4, I would get a negative 81, because that's what the negative 3 times 27 would give me. And on the bottom, 16 times 4 would give me 64. So I'd get a negative 81 over 64. So that does check out, right? So the answer to the last one is yes. And my R is negative 3/4. And again, if you wanted to see that in a mathier way, that's totally fine. The mathier way to see that is that you would put negative 9/4 over a 3, right? Which, if you clean that up, is a negative 9/4 times a 1/3, which is how I get negative 3/4. And you could do that with all of those fractions, and you would find that they all have the same ratio of negative 3/4. So again, B and C were geometric, and B and D were geometric, my bad, and A and C were not. A was arithmetic, not that we were asked that, but it is, and C is essentially just the terms being squared, right? 1 squared, 2 squared, 3 squared, 4 squared. It is neither arithmetic nor geometric.